Hello students, we are learning lesson number 9 and in video number 7 we had started solving the problem sums, that is the solved illustrations. Now see page number 121, this is example 9.3. A motor car is moving with a velocity of 108 km per hour. This is velocity and it is moving with velocity of 108 km per hour means its initial velocity is 108 km per hour. So we will be writing this way: u is equal to 108 km per hour, and whenever the unit of velocity is given in kilometer per hour, always convert it into meter per second. So 108 km, to convert into meter we have to multiply 108 by 1000, and 1 hour means 60 minutes. 60 minutes is having 60 seconds. We are going to convert it to seconds. So first of all 1 hour into 60 minutes and the 60 minutes again into 60 seconds. So multiply 2 times, 60 into 60. After cancellation we got 30 meter per second. So motor car was moving, it is moving with a velocity of 108 km per hour, that we have converted into meter per second, that is 30 meter per second. It takes 4 seconds to stop after the brakes are applied. So it takes 4 seconds, t is equal to 4 seconds after the brakes are applied. Whenever in any sum it is said that brakes are applied, always you see if the brake is applied the vehicle is going to stop. So final velocity will be 0. So v is equal to 0. Although it is not written then final velocity is 0, but as the brakes are applied we have to write v is equal to 0. Calculate the force exerted by the brakes on the motor car. Force exerted on the brakes means F is equal to dash. We have to calculate on the brakes on the motor car. If the mass of the passengers is 1000 kg, mass means m, so m is equal to 1000 kg. Now we are having V, T, M. We have to calculate F, and here V is given 0. And the initial velocity is u, 30 meter per second. So we know that Newton's second law, F is equal to ma, and in place of a we will write v minus u upon t. So this formula we got. Go on placing the values. F is equal to 1000 kg in place of m, and in place of v you are going to write 0 minus u is 30 meter per second upon 4. So 1000 into 0 minus 30 is minus 30 upon 4. So we will get 425s are 100, so it is 250s are into minus 30. So 250 into minus 30 got 7500 N. It is F, so Newton is Newton, unit is Newton, capital N, and minus. The minus sign shows that is a frictional force acting on the object in the opposite direction. So wherever the force means the car is moving in the forward direction and the brake stops it, so the frictional force will be opposing its motion, that is minus. So the minus sign is there. So it is written, the negative sign tells us that the force exerted by the brakes is opposite to the direction of the motion of the motor car. Now you see the next sum, example 9.4. Example 9.4, two data are given. One is a force of 5 Newton gives a mass m1. So force of 5 Newton, right? F is equal to 5 Newton, mass m is equal to m1, mass of m1. And then it is written an acceleration of 10 meter per second square. That means the force of 5 Newton, when the force of 5 Newton is applied on a mass of the object m1, on the object which is having mass m1, then the object is accelerated to 10 meter per second square. That means its speed increases by 10 meter per second per second. So now you have to calculate. Now these three datas are given, F, M and A1, and here M1 is unknown, and we have the fixed formula of the second law, that is F is equal to M1 into A1. So we will have whatever we are having, go on placing the values. So F is 5 is equal to M1 is M1 into 10. So M1 you make subject, that will be M1 is equal to 5 upon 10. So M1 is equal to 5 upon 10, that is 1 upon 2. So when we divide 1 by 2, we will get 0.5. So this we got M1. And after that, again read the sum. First one was a force of 5 Newton gives a mass m1. M1 we found out 0.5 kg. An acceleration of 10 meter per second square. And a mass m2, an acceleration of 20 meter per second square. That means if the mass is m1, then acceleration will be 10 meter per second square. the mass is m2 with the same force. With the same force, if we are pushing an object having mass m2, then the acceleration will be 20 meter per second square. Again we have to find out m2. Then what acceleration would it give if both the masses are tied together? So first of all, let us find out m2. So it is F is equal to 5 Newton with the same force we are pushing. M is equal to m2, A is equal to 20 meter per second square. So F is equal to m2 into A2. So 5, F is 5, 5 is equal to m2 into 20. So m2 is equal to 5 upon 20. Bring this down, 5 upon 20, 5 was a 5, 5 was a 20, 1 upon 4. If you divide 1 by 4, we will get 0.25, and this is kg because this is mass. You have to write the unit m1 kg. Now both the objects are tied together. If both the masses are tied together, then the total mass m will be m1 plus m2, that is 0.5 plus 0.25, we will get 0.75 kg, and force remains the same. And at this situation we have to calculate the acceleration. In the sum it is written what acceleration would it give if both the masses were tied together. You have to find A. So F is equal to ma, so A is equal to F upon m. So F is 5 and m is tied together, so it is 0.75. So we'll write 5 upon 75 upon 1000. That means 5 divided by 75 upon 100. Divided by. So change this division sign into multiplication. So the second one, the denominator will go up and the numerator will come down. We have to make the inverse. 5 into 100 upon 75. So 25 3s are and 25 4s are. So we'll get 5 into 4 upon 3 is equal to, that is 5 4s are 20, 20 upon 3. Now this 20 you divide by 3. 20 you are dividing by 3. 3 6 are 18. So 2 we are getting, and 1 decimal point we have put, take 1 0, again 3 6 are 18, 2 we are getting, you can take 1 0, again 3 6 are 18. This way you go up to 3 decimal. After going up to 3 decimal, now you see we have to write the answer up to 2 decimal. So we will get 6.67. Why 67? Because this figure, the second figure is 6, and after that the third figure is actually 6. If the third figure is 5 or more than 5, then to make the approximate value we have to add 1 in the second figure. Suppose the answer would have been 6.664, then we would write 6.66, but as it is 6.666, the third one is more than 5. If it is 5 or more than 5, then the number preceding it will add plus 1. So we get 6.67 meter per second square, and that is your answer. So this way we have solved the third sum. Sorry, we have solved the fourth sum. And now the fifth one is remaining. Fifth sum. Now for the fifth sum, see the velocity of the time graph. Velocity of the time graph of a ball of mass 20 gram. So as it is given mass 20 gram, we'll go on writing the data. We got m is equal to 20 gram. As it is given in gram, always convert it into kg. That is 20 upon 1000, we get 0.02 kg. 0 0 cancel. 2 upon 100 means 0.02 kg. So it is written the velocity of a time graph of a ball of mass 20 gram moving along a straight line. This is the graph of an object given when it is moving along a straight line. Mass of the object is 20 gram. On a long table, that is on a straight line on a long table is given. So this is the data given. Now if you see the initial velocity, this is velocity, it is given in centimeter per second. The initial velocity is 0. No, the initial velocity is 20. When the time is 0, initial velocity is 20. So we have to write u is equal to 20 centimeter per second. And if you look at the final velocity, this is the y-axis is showing velocity. In the y-axis, the initial velocity was 20, then the velocity goes on decreasing, and now the final velocity is becoming 0 because final velocity graph is lying on the x-axis. This is 0. Initial velocity is 20, then it is decreasing, and final velocity becomes 0, and the time taken is, here it is written 10 seconds. So we'll write final velocity is 0, time is 10 seconds, and in decreasing the velocity to 0, then how much force is required, that you have to calculate. Here it is written how much force does the table exert on the ball to bring it to the rest. That means one ball is rolling on the table like this. Suppose the pen is rolling, instead of pen, if it would have been a ball, it is rolling on the table straight, on a straight path. Actually the table is having a rough surface, it is opposing the motion of the ball. Now when the ball had started its velocity, that is motion, the initial velocity was 20 centimeter per second, and after 10 seconds the ball comes to rest. So to bring the ball to rest, how much force the table exerts on the ball? That means you have to calculate the frictional force applied by the table. So in this case, F is equal to, F you have to calculate, F is equal to m into A means V minus U upon T. Then place the values. After placing all the values, we got, it is minus 4 upon this, so minus 4.0004 Newton. It is minus, that means it is frictional force. So negative sign shows that the frictional force exerted by the table is opposite to the direction of the motion of the ball. The calculation I have shown here. That's all in today's video.